to study quickly how compounds react, we actually need to study how compounds exist in solutions because it varies. Now, before we do that though, I need to go over a couple of key terms. The first one is solute. Now, a solute is the substance that is going to be dissolved. So for example, if I have salt water, salt is going to be the solute. The solvent is the substance that dissolves the solute. So for example, for salt water, the solvent would be water. Now, the important thing for you to know about solvents is that they're present in the greatest amount. So if I have salt water, the salt being dissolved into water, then I definitely have more water than I have salt. One thing for you to know, when a substance is dissolved in water, it has the capacity to make the water capable of conducting electricity. Now, if you have pure water, pure H2O, and you put electrodes into that water will not conduct electricity. If you add a molecular compound, so for example sugar, that will also not conduct electricity. If you add salt, however, that will conduct electricity, and therefore we call the sodium chloride solution an electrolytic solution. Sodium is an electrolyte, so let's actually look at what that means. Electrolytes form ions when they're in solution. So if you look at the diagram below, the first one, A, there you have sodium chloride. And what happens when sodium chloride is put into water is that water molecules surround each of the ions. Now keep in mind sodium has a positive charge, so the partial negative sections of water, the oxygens, those are going to be attracted to the sodium ion, while the partial positive charge that's on the hydrogen will be attracted to the negatively charged chlorine. When ions are surrounded by water, that process is called solvation, and it actually stabilizes the ions so that they don't reform an ionic compound. By surrounding each of the ions, water enables the ions to actually disperse throughout the solution, and that's how you get, for example, salt water. That's how you get a homogeneous solution. When you're dealing with a molecular substance, however, if you look at B, it does not form ions in solution, and therefore methanol or any other molecular substance, those are called non-electrolytes because they don't form ions. So electrolytes do form ions, like in A with NaCl, and B, as you can see, it dissolves, but when it dissolves, it does not break up into ions, and therefore it is a non-electrolyte. So looking back at the concept of conductivity, non-electrolytes do not conduct electricity because they do not break apart into ions. One mathematical concept that helps us in order to study electrolytes is called the Hoff Factor, and the Hoff Factor calculates how many ions are formed when a compound dissolves based on one formula unit. So for example, NaCl. NaCl, if I had one formula unit of NaCl, I would have one sodium ion and one chlorine ion that are formed. Therefore, my Hoff factor would be 2. Let's look at another example. If I have Na3PO4 and I put that into water and allow that to dissolve, Na3PO4, because it is an ionic compound, it is an electrolyte. Therefore, it's going to break apart into its ions. So you have sodium and you have phosphate. Keep in mind, I have 3 sodiums and I have 1 phosphate ion. Therefore, it's going to be 3 NAs and 1 PO4, and I represent it this way. Notice I have 3 NAs, which each have a +1 charge, and I have 1 PO4, which has a -3 charge. Therefore, since Na3PO4 broke apart into 4 different ions, my Hoff factor is 4. Up until this point, we've been talking about electrolytes versus non-electrolytes. One last thing that we need to do is to distinguish between strong electrolytes and weak electrolytes. Now, in a strong electrolyte, the solute exists in solution completely or nearly completely as an ion. And so the way that we represent that is with this formula. If you notice HCl, which by the way is an exception because it is a molecular compound that is an electrolyte, but anyways, HCl is going to break apart into its ions, into hydrogen ions and into chlorine ions. Now, notice that there is one single arrow and it's pointing in the right direction. What that means is that your hydrogen and your chlorine, they're going to exist as ions. They're not going to exist as the neutral compound and there's no tendency for those ions to want to reform the molecular compound of HCl. Instead, they're going to exist as ions. In contrast, when we're talking about weak electrolytes, your solute exists mostly in the neutral form as a molecule, and there are only a few ions. So the way that we represent that is with the double arrow. Notice this is acetic acid. Acetic acid will break apart into the acetate ion and the hydrogen ion, but notice that there is a double arrow, and so what that double arrow tells you is that while those ions can exist, they also have a tendency of going back, reforming into the neutral molecule of acetic acid, and therefore that's why they are weak electrolytes.